Hi, welcome back. We're on the next part of the sample test for a circuit analysis course, or actually more like a circuit analysis 2 course in some places. And we've got here a more complicated circuit this time. This time we've got a nice little op-amp, and we've got some other circuit helping drive the op-amp. So what we've got to do here is we realize there's a voltage-controlled current source right here at I1. We've got a fixed voltage source V1, and we've got a fixed current source I2. What we've got to do is we've got to find the voltage across R6 Vx right here, and we're asked to redraw any circuits that if we do any circuit reduction here. So if we're going to do it by superposition, for example, and we start turning off current sources, we've got to draw our equivalent circuits. So what I'm going to do on this one, since this is we're just trying to understand what's first we want to learn. We also want to learn how to take the test. So we're doing two things. So what I'm going to do is I'm going to solve it two different ways. First, I'm going to do it by not using superposition. I'm going to just put some Kirchhoff's laws into effect, put in some currents into these loops, analyze the circuit. From there, I'm probably going to end up with a matrix and might have to do some linear algebra to solve it. Also, it's good to understand this op-amp right here. Right off the bat, what you should look at is, hey, is it an inverter? Or is it not an inverter? We can see that we've got negative feedback because we've got the output connected to the input. So that's definitely. So this is this will. So you've got. So is it an inverter? Ooh. It's not an inverter. So this one's not an inverter. You've got this voltage right here driving the positive input. So it's not an inverter, but it does have some negative feedback right here. So that's something to know. So we'll look at that as well. Also, I think we're assuming the op-amp is ideal. So in an ideal op-amp, there is no current driving into the op-amp. So the current right here, I'll just call it I/O, must equal 0 in the ideal world. So when we analyze this circuit, really we're just looking for the voltage. We're not looking for any current. That should help simplify our lives a little bit. Okay, so without any further ado, I'm going to redraw this to get a nice clean copy, and we'll do some. In fact, I'm going to stop the video here, then go on and do the current loop analysis, stop it again, and then do superposition. Thanks.